n equals to 6, we have 6 nodes, and k equals 2. So we begin with node 2. So here we have 6 nodes and begin with 2, and we have different time between different nodes, like between the 1 and 6 is 7, between 3 to 5 is 4. So we have to calculate, if we have a signal come here, how much time we have to let the signal travel all the nodes. So basically, we have to calculate each node. Basically, we have to calculate each node's distance to the entry. For example, we have to calculate for node 6 how much time we need for 6 to get signal travel to here. And here the example is like we have the shortest path is 1, 3, 1 is 5, right? And also we have to calculate for 5 is 1, 4 is 5. So essentially we calculate for each node, and then we put the value into array, and then we get the largest value in that array. So that will be the answer. Distance. This is about visited. So when we visit one node, we will mark the node as visited. It is a boolean, so if it is visited, we will mark as true. And the distance is, let's get started. So we start from node 2, right? We put a star here, and then immediately the distance at this point is 0, because when the signal come here, it immediately go to the node 2. So distance here is 0. And then we have to find out the neighbors for the node 2. The neighbors is 2 and 3. Okay, so we need to check the distance for 3. What's the distance from for 3 to the signals? You can see we only have the this amount, this distance. So distance is 1. And the distance for the 1 is actually 2. Okay, so at this moment we have traveled all the neighbors for node 2. So we can mark the node 2 as visited. Okay, now, so which node will be the next we're going to check? So now we have to compare for this array. We have to find out the least distance the array have. So here is the 0, but the 0 was already checked, was already visited before. So we ignore this node. So we can find that the node 3 has the least distance. So now we go to the node 3. Okay. Now we have to check for the neighbors for all the neighbors for node 3 is 5, 4, 2. The 3 have 3 neighbors. So we have to check one by one. So for the neighbor 2, the 2 already checked, so we skip. So now we're going to check node 4. So what's the distance for 4? So for 4, the distance is like between 3 and 4, this distance is 3. And then we have to add the distance on this point, on the 3. So here is 1, so we have to 3 plus 1 equals 4. Distance for 4 to get that signal is 4. Now so now we go to check the 5. The 5 is the neighbor of the 3 as well. So what's the distance for 5? So here between the two nodes, the distance is 4. So we'll put 4 here, and then we have to 4 plus the distance at this point. So the distance at this point is 3 is 1. So what's the meaning of the distance at this point? It means that the distance at this point is the distance between this node and this node. between the node 3 and the beginning node, so which is 1. It's 4, it was 5. So we can see there's no information here, so we put 5 here. Okay, at this moment we have checked the 1, 2, 3, the 3 neighbors of node 3, so it means that we have done with node 3. So we put the true here. It means that we have already visited the node 3. Okay, the next, who I'm going to check for the next round. So as we did before, we have to check this array. Who have the least distance, and at the same time didn't check before. So we already checked the node 2 and 3. So we don't need to consider about the 2 and 3. We compare this node and this node. At this moment, we can see the node 1 has the least distance to the engine. So now we check with node 1. We put a star here. Okay. And now we have to check the neighbors for node 1, which is 2, node 6. It has 2 neighbors. However, the node 2 was already checked before, so we don't need to check at this point. We only check the neighbor 6. Okay, so what is the distance for node 6 to get the entrance if we travel on this road? Okay. So we can see the distance between the 1 and the 6 is 7. And then we have to add the distance at this point. The distance at this point is, so we can go to this array to find this one is 2. 9. So we can calculate if we travel in this way, we need the distance is 9. But are we going to put the 9 at this? Yes, because here is empty. We have to put the information here. Okay, now we have to move to the next node we're going to explore. So again, we have to check this array. Who is the least distance in this array, and which also didn't check before. So here, the node 1, 2, 3 were checked. So this part, we are going to ignore this part. We're going to compare these 3 nodes. So here we can find the distance for node 4 is the least distance among the 3 value. So now we're going to put our star here. We do our work here. We have like 1, 2, 3 node for node 4. So however, the node 3 is already checked before. So we skip this one. And then we go to node 5. Okay, so for node 5, if we travel from node 4, what is the distance for 5? We can see the distance is 3 plus the distance at this point. What is the distance at this point? We go to this array, we find node 4 is 4. We can see that the number is 7. So here we calculate the distance here is 7. Should we update this value? And here, the answer is no. Why? Because this distance, the previous distance is shorter than this one. So we're not going to do anything. We ignore this part. We ignore this value. So this is very important. So here we get the distance 7, but we don't update here. This is very important step. we're doing this question. Okay, so we already checked 5, we're going to check 6. After 5, we're going to check node 6. So what's the distance at 6 at this moment? So firstly, we find out the distance between 4 and 6, which is 1, right? And then we have to add 1 to the distance at this point. So what's the distance at node 4? Here is 4. So 1 plus 4 equals 5. So it means that if we travel in this direction from node 4 to node 6, the distance at the node 6 is actually 5. Okay, here's the problem, pay attention. So the 5 is larger than the previous distance, 9. Okay, so 5 is smaller than the previous distance, 9. And then we're going to update 5 to 9. We're going to remove 9. We put the 5 to here. Okay, so the 6 is done. So at this moment, all the 3 labels was all checked for 4, so we have to mark 4 as visited before. Okay. Let's go to the next round. Again, we have to check this array. Who is the least distant value? So here this 4 nodes was already visited, so we have to compare the 5 or 6. It's actually the same value, so we go either way. So now we can begin at number 5. So now we move our star from here. However, the 5 have nothing to do because the 5 neighbors 3 and 4 already checked. So the 5 have nothing to do. If we go to here and nothing to do, we move on. So 5 is checked, and also we have one last point is the node 6. So node 6 is the least value for node 6. There's nothing to compare. We move our star here. Just like before, the neighbors for node 6 is 4 and 1. 4 and 1 is already checked, so there's nothing to do for node 6. So we go over. Okay. So we have to mark at this as check. So at this point of view, all the nodes was all visited. And then we get a final answer for the distance for every node. For example, for the node 6, the least distance is 5. Okay, so the question is, what is the final answer for this question? Okay, so what is the final answer for this question? The final answer is that we have to compare all the values here. We find the largest value. We find the largest distance for every node. So here, we find the largest distance is 5. So here, we find the largest distance for the array, for the nodes, is 5. So both find the same. So the final answer for this question is 5.